Alrighty folks, this is your tutorial on the Unit 10-6 homework assignment. Your job was to complete the entire backside. So I would probably work out just half of them, like the odds only from the backside is what I will work with you. But again, your job is to complete the entire backside. So for section 10-6, it was day 5 of our notes, and there was 3 different formulas on that set of notes. For number 13, when I look at the situation, I know that angle 1 is inside my circle, so I'm going to use the formula for inside the circle. The formula for inside is angle is equal to arc plus arc divided by 2. So in this case, angle 1, which is what I'm looking for, is equal to arc LP plus arc RQ divided by 2. So that means 50 plus 56 divided by 2. And this can be done all in one step. It is very important that you understand what arcs are related to the angles. That I like to think of it as the angle giving the arc a hug. So if the angles is not hugging the arc, then you cannot use it in the formula, and vice versa. So what I'm trying to say is angle 1, this angle here, is touching arc RQ, but its vertical pair is touching LP. So that's why I use those two, and only those two. I cannot use L to R or P to Q. Just keep that in mind. Back to my problem. So I could type 50 plus, well, too many pluses, 56 divided by 2. Notice I put it in parentheses. This is so I don't have to go do alpha y equals 1. But if I did not put parentheses, I would not get the right answer. So it is 53 degrees. All right, number 13 is next. On number 13, we're looking for the measure of angle angle 3. Angle 3 is on the circle. And the arc that it is related to is arc MP. And as we can see, MP is 198 degrees. So when the angle is on the circle, the formula for on is angle is equal to arc divided by 2. So that means the measure of angle 3 is going to equal 1 arc MP divided by 2. So that means 198 over 2, which is 99 degrees. All right, number 17 wants us to find the measure of angle 5. Angle 5 is right here, and angle 5 is related to arc DB and arc EA. But unfortunately, I don't have the measures of those arcs. I have the measure of arc ED and AB, which means I can find this angle. So this is going to be a two-step problem. Regardless, the angles are inside the circle. So I'm going to use the formula angle is equal to arc plus arc over 2. So I don't, we don't need to know the angle's name. So we'll just say angle is equal to arc ED plus arc AB divided by 2. So ED is 66, AB is 50. '66 plus 50, all of that divided by 2 is 58. So this angle is 58. But again, wait, I'm not done. The angle I just found together with angle 5 form a linear pair, which means that they are supplementary, which means they add to equal 180. So I should be able to take the measure of angle 5 plus the angle I just found and equal 180 degrees. So I'm looking for angle 5 again, plus the angle I just found is 58. And again, together they equal 180. So I would subtract 58 from 180 to get angle 5 by itself. And that's going to be 127. Sorry, 122. 122. So angle 5 is 122 degrees. All right, number 19. We're looking for angle R. Angle R is outside the circle. So outside's formula is angle equals arc minus arc divided by 2. So the measure of angle R is going to equal the measure of arc PV, because it's the bigger arc, minus arc QT divided by 2. So that's 120 minus 40 divided by 2. And we get 40. So angle R is 40 degrees. For number 21, we're looking for the measure of angle U, which again, angle U is outside the circle. So again, we're going to use angle is equal to arc minus arc over 2. So the measure of angle U is equal to arc SW minus arc TW over 2. Now, currently, I don't have SW, but I can find it because this circle is broken into three parts. S to T is one part, T to W is another part, and S to W is the third part. So I can take the two values that I have and subtract them from 360 to find the missing part. So subtract 144 and subtract 60, and I get 156. So SW is 156 degrees. Now I can answer my question and find the measure of angle U. So SW is 156 minus TW, which is 60, all of that over 2. And we get 48 degrees. And last but not least, number 23. Number 23 wants us to find the measure of arc DPA. They give us the angle DEA, and that angle is outside the circle, or you could say angle E. So since angle E is outside the circle, we're going to use the outside formula. Again, angle is equal to arc minus arc divided by 2. So the measure of angle E is equal to the measure of arc DPA, it's the bigger one, minus the measure of arc DA, the smaller one, divided by 2. Now again, notice I don't have any values for those two arcs. So let's say I call arc DA X, then DPA is going to have to be 360 minus X because the entire circle is 360 degrees. And if it's split into two arcs, then the two arcs combined need to equal 360. And if I say that one of the arcs is X, if I want to know the other piece, I would take the piece I'm given, X, subtract it from 360, which is what I've done. So now I'm going to put everything where they belong. This is key, folks. Angle E will go on the left side of the equal sign. Arc DPA is going to be replaced with 360 minus X. And arc DA is going to be replaced with X. Now we are going to put 84 over 1 and then cross multiply. So 1 with that would give me 360 minus X again is equal to 2 times 84, which is 168. I have two X's I need to combine. So that will give me 360 minus 2X is equal to 168. I have two options here. I would probably subtract 360 from both sides, which would leave me with negative 2x is equal to 168 minus 360, negative 192. And then divide both sides by negative x. I'm sorry, negative 2. And I get 96. So x is 96. What did x represent on our picture? X represented dA. But we need to find dPA. So we still need to take 360 minus x. So 360 minus 96 to get our final answer. So 360 minus 96 is 264. So 264 degrees is the measure of arc dPA. And this concludes your tutorial. Again, make sure you finish the other problems on this backside.